Today I'm showing you how I actually reduce the blast radius on my development machine. Not theory, the actual setup, the actual tools, the actual trade-offs. If you watched the last episode, you know why this matters. Today is the how. This is a simplified version of my real setup. The full one has more on top, and I'll give you a quick look at that at the end. Repo link and credits are in the description. The first thing I did was to get rid of private SSH keys on my disk. The tool I use for this is 1Password. For me, it was a natural fit, as I have been using 1Password as my password manager for years already. So first, I enabled the SSH agent in the 1Password settings. Next step was to import all my existing keys. You can create new keys as well, so let's try it. OnePassword also gives you a nice overview over the active SSH keys here. But why is a new key not listed here? This was actually the trap I myself ran into. Not all added SSH keys are actively used by the SSH agent. You have to specify which vaults are scanned for the SSH keys by editing this config file. As you can see, only my personal vault is active, so let's add the new vault. Our new SSH key is immediately added to the active key list in the SSH agent. However, enabling SSH agent alone is not enough. We also have to configure the SSH to use the agent. This is done by adding these two lines to the config. They tell SSH to use the 1Password agent for connections to all hosts. The path you see here is macOS path. If you want to use 1Password SSH agent on Linux or Windows, please check the documentation link in the description. Now you can remove all your private keys from disk and also from the SSH config. And instead, just to help the SSH agent to select the right key for a host, link your public keys instead. You can easily download the public keys from 1Password and store them in your SSH directory. Now let's try it out. When you make an SSH request, the SSH agent asks for the permission to use your key for the current application and terminal session. And if you give your permission, the connection can be successfully established. SSH keys are off disk, but keys are only one part of the picture. Most projects also need secrets: API keys, database URLs, tokens. And those traditionally end up in .env files, scattered across every project directory on your machine. Same problem, different shape. Fortunately, 1Password has a CLI that solves this in a similar way as SSH keys. Credentials stay in the vault and only reach your application at the moment it needs them. I already created a test secret for us to play with. Let's try reading it with the CLI. And again, you need to approve the request to the secret. Though this is sometimes very handy, I do not use this command a lot in my development process. What I use instead is the run command that lets me run a process with environment variables set by 1Password before the execution. All it needs is to know which variables to set, and they are defined in a template file, very similar to the .env file, but without actual secret values. Here I have an example of such template file. It looks almost identical to the regular .env, but instead of using values, you use secret references. You can, however, use values as well, as not all variables are secrets. Now let's try it out. As you can see, the secret gets concealed by the CLI, which is a great side effect of using the run command. And there are two much bigger benefits. The resolve secret values only exist as long as the process runs. They are all gone as soon as process ends, and you can commit the template file to Git as it contains no confidential information anymore. Here is how I use the run command in my projects. Now, sometimes you still need environment files. Some tools still require them. And here you can use the inject command. This one prints a resolve template to standard out so you can store it to a temp file, use it, and delete it afterwards. Keys and secrets are off disk. Two problems left, both about the code itself. It's still running directly on my machine, and it's still got an open line to wherever an attacker wants to phone home. Dev containers close both, move the untrusted code of the host, and cut the line to home base. Let's jump in. What is actually a dev container? A dev container is a regular Docker container, configured as a full development environment. Your code, tools, and runtime all inside the container. VS Code's dev container extension lets you work in VS Code on your host where everything actually runs inside that container. Native convenience, isolated execution. Now I will show you the minimal dev container setup just to illustrate the base I built my environment on. The main configuration file for the dev container is devcontainer.json, and it must be located in the .devcontainer folder. Let's quickly go through its content. First is the name. This name will be shown in the Project Explorer when running the container. Next, the container image. You can either use a ready-to-go image or, as I did here, specify the custom Dockerfile to run your container. I do add some custom tools and scripts to my container, so I went with the custom Dockerfile option here. Next, the run args. These arguments are passed straight to the Docker run command. The first two are necessary for my firewall setup that I will explain later, and with the last two I specify an environment file for the container. I will show you later how this environment file is generated and why I need it passed exactly this way. Next are mounts. You can mount any Docker volume or directory here, so it will become accessible inside the container. But please keep this list to a minimum, because every folder you add here also increases the blast radius in case something goes wrong. I only mount the SSH aus socket here, so I can keep using my 1Password's SSH agent from within the container. This source path, however, is only available on Docker Desktop for macOS. Docker Desktop reads the host's SSH aus sock environment variable to know to which agent to forward. And if the variable is not set, the mounted socket will be empty and SSH will not work in the container. To fix it, just add this line to your shell profile. I have added it to my Z-shell profile. Please check the documentation for Linux and Windows settings, but it should work very similar. Just the paths will differ. To finalize SSH configuration, you will also need to set the SSH aus sock in the container as well, now using the mounted path. Next are the three lifecycle hooks. When the container starts, they get executed in the following order. Initialize command is executed on host before the container starts. Post-create command is executed inside container after the container is created. And the post-start command is executed inside the container after container is started. And with wait for, I specify that I want the post-start command to complete before starting my work inside the container. And finally, the workspace mount and folder. The workspace mount binds a local open folder to the workspace folder, and with the last line, I define which user will be running the container. And as always, never use root for security reasons. We are hardening our setup, right? Now let's take a look at the Dockerfile. Mine is fairly simple. It is based on Node image. Since my project is a TypeScript project, it was an obvious choice for me. Then I add some tools. Most of them are required for my firewall scripts. Next is a copy command. I bake all my internal scripts into the image so they are not editable in the running container, and I can safely add them to the sudoers list. All my firewall scripts require root permissions, so we need to add them to the list of scripts allowed to be run with sudo. And that is it for the Dockerfile. Let's look into my firewall scripts. I will not go too deep into details on each one of them, but only quickly explain what they are for and what kind of technologies they use. You can check out the scripts in the repository linked in the description later if you want to dive deeper into the how. The main script is the firewall.sh. It uses IP tables to allow outbound access to only configured hosts. Furthermore, it blocks the DNS access for the regular container user to eliminate the DNS query exfiltration attack, where attacker embeds sensitive information inside DNS queries. This script is meant to be executed on each container start, so the firewall is up and running during the development process. The allowed domains can be configured here in the .allowed domains. So the firewall blocks all requests that are not part of this list, but sometimes you need a temporary access to some host. It would be rather cumbersome to add the host to the allowed list, restart container, make the request, remove the host from the list, and restart again. So to make the life easier, I also added allowdomain.sh script. You can run the script inside container to temporarily allow access to a host. The script resolves the IP of the host. Since it is running at the root, it has access to the DNS, and adds a new IP to the allowed IP set. The script also logs all the allowed hosts and their IPs, so I can check what was allowed and when. But how do you know which domain to allow? A tool is suddenly failing and you have no clue why. And even if you get a good error message, which domains does the tool need? This is exactly the responsibility of the third script, capturedns.sh. This script listens for the DNS queries. Since DNS queries are only made in case of not yet resolved domain, it would catch all the requests to the blocked domains. And those domains are added to a log file in the .devcontainer directory. So if something is not working, you can check this log and add new domains to the allowed list if necessary. This script serves yet another purpose too. It will discover hosts that are being accessed without you even knowing. So we have our Devcontainer config, our SSH socket, and the scripts for the firewall are ready to be used. The final question to solve is how to make the secrets work the same way they do on the host. The 1Password CLI will not work the same way it does on the host machine. We do not have the native app integration there. The solution to the problem is using the service accounts and their tokens to authorize CLI requests, rather than using personal account as it is done on the host. The service account is just a machine user that has a credential and permissions for certain actions on selected secret vaults. Short explanation on vaults. Vault is 1Password organizational unit. If you have access to the vault, you can access all the secrets within. Which for our case means we have to limit what the service account can reach, so never give a service account full access to your personal vaults. And here's what I do. I create a vault for each of my projects and I only put project relevant secret there. I also create one service account for each project and give it only read permissions to the project vault. This is for the case the service account token gets exfiltrated, then only my project secrets get exposed, nothing else. I also recommend having a dedicated vault for all your service accounts just to keep everything nicely organized and not mixed with your personal credentials. I already created a vault for this project and the matching service account. If you're interested in details, check out the README for this project. All the commands are listed there. Now, how can we inject the service account token into the container without adding it to the container env in the Devcontainer config? This is exactly where the temporary environment file together with the initialize command comes in. In my oninit script, I just run the read command to get the token and add this token to the temporary environment file. This way, I can commit all my scripts and they contain no confidential information whatsoever. This temporary file exists for a very short time window. As soon as container is started, the file is removed. As we are already in the oninit script, let's talk about the second responsibility of the script. The script also prepares the SSH config that will be used in the container. If you only have one SSH host, you will probably not need this config. But in my case, I copy all the public keys from the host and also grab the references to them from the host's SSH config and add them to the container. This way, I can help 1Password decide which key to use with which host from the container as well. In the oninit script, those files are just prepared and stored in the temporary folder, since this script runs on the host. Let's look at the other two lifecycle scripts. The onCreate script is run after the container is created, so you can put all steps here that should run once inside the container. My script is empty as I do not have anything for this phase. The final script is onStart. This one runs on the container after container has started and after the onCreate script is executed if the container is started for the first time. In my case, we copy all the SSH public keys and the config to the final destination and delete the temporary folder. This is also the place where the firewall and capture DNS processes are started. Now you have everything you need to understand what happens when we start this container. Let's go! When you open a project with .devcontainer folder inside the VS Code, it automatically detects your configuration and asks if the project should be reopened in the container. You can also open the project in the container manually by pressing Command-Shift-P and selecting Devcontainer's Reopen in Container. Let's reopen the project in container. The first thing VS Code does is run the initialize command, and we get the permission prompt to allow 1Password CLI access to the service account token. Next is building the container, but only if running for the first time or on configuration changes. Then the container is started and the lifecycle hooks post-create and post-start are executed. And now we are up and running. Let's test out the SSH. The shell I opened here is a container shell. The workspace is mounted at /workspace. Now let's run the SSH command. And as you can see, it works from the inside of the container the same way it worked on the host. The access to the GitLab is permitted because it is configured in the allowed domains. Let's try to access a secret. I forgot to install the 1Password CLI to this container, so let's fix it. Now we need to rebuild the container. Hit Command-Shift-P and run devcontainer rebuild container. The start fails, and you get the full log of the startup sequence opened in the editor. Let's check. Here is a culprit. I forgot to add the unzip that I use in the 1Password install command. Let's fix it. And now let us rebuild one more time. Fantastic. It worked like a charm. Let's try to access the secret one more time. And here we go. The secret is available for us to work with. By the way, you do not need to specify the account in the command anymore if using the service account token. Amazing. Now let's try to install all the project dependencies. Takes quite a lot of time. Okay, we got an error here. Let's open the log. And here we go. npm failed to fetch the registry. Let's look in our DNS log. And as expected, the registry host got blocked by the firewall. So firewall is working. Let's allow this host and try the installation again. And now it worked. But we need to add the host to our permanent allow list, so it is still allowed on restart. And that's it. That is the base for my actual setup. The SSH keys are gone from the disk, the secrets are all neatly stored in the secret manager, and development processes are running inside an isolated environment with only deliberate outbound access. I think I mentioned a couple of times already that this is not my real setup, but a base for it. I actually started just like that. Maybe with a bit more tools here and there, but I quickly realized that this solution, even if it works, is not scalable. I have different projects with different tool needs and configurations, so adding all of that to one unified configuration will just make the image bloated and make the attack surface considerably higher. So I switched to a modular approach. Fortunately, Devcontainer supports this modularity out of the box with features. Features, in essence, are just install scripts that get executed after the base container is started. So I built a couple of features and also a base image that contains all the base tools required for the security foundation of my setup and some quality of life tools that I typically use in all of my projects. I will now show you the demo project, but using my actual setup. The features come from a private registry, so you won't find them in the demo repo, but the core structure is identical to what we just walked through. So here's a new Devcontainer JSON. I use my base image here instead of building a custom one. I sometimes actually do use custom Dockerfile for my projects, but I always use this image as base. No changes to the run arcs, but here is the main difference. the list of features or components I need for this project. I intentionally kept it very simple, only using same features as we did with the simple setup. This is it. The file is very small now. Let's go over lifecycle script changes. On init script is mostly the same. However, since I copied the script between my projects, I moved the configurable parts like 1Password secret reference to the host.env file. The other two scripts are baked into the container, so no need to have them in the project. I would love to move the init script to the container as well, but since it runs on host before the container even starts, it is not possible. And that's the setup. SSH keys out of the .ssh, secrets out of the .env files, and your code running in an isolated environment that can only talk to the outside world on your terms. Is it more work than a default setup? Yes. But it's also the kind of work you do once and then just use. And every time something tries to phone home unexpectedly, you'll know about it. The demo repo is linked in the description. Everything we walked through today is in there, including the firewall scripts and the template files. Clone it, break it, make it yours. If you have questions or run into something unexpected, drop it in the comments. I read them all. See you in the next one!